Good morning. This is the AP Calc video for L'Hopital's rule, which will actually help us take some limits that we didn't know how to take. It's also a good review here at the end of some of the things we remember about how to take limits. So, a reminder, when you're asked to find a limit, we're always going to try direct substitution first. And sometimes that works. And remember that if it doesn't work, that doesn't necessarily mean the limit doesn't exist. We may have to maybe do some factoring and some canceling and then use direct substitution. Or let's approach infinity. We might have to pay attention to where the biggest exponent is. We have different methods to use or to evaluate limits. Well, now that we know derivatives, which of course we've known for a while, there's this L'Hopital's rule, which will help with lots of these. So even some of the ones that we could easily do other ways, L'Hopital's rule works great. And it says this. It says if direct substitution leads to either 0 over 0 or infinity over infinity. Those are called indeterminate forms, which doesn't matter much, that name. But if direct substitution leads to either of those, then it turns out we can use L'Hopital's rule. L'Hopital's rule says this. It says the limit of f of x over g of x, if I have a fraction, one function over another fraction, equals the limit as x approaches c of f prime of x over g prime of x. So that means you can literally take the derivative of the top and the derivative of the bottom and then use direct substitution. Understand, this is not a quotient rule. We're not taking the derivative of a quotient. We are literally just taking the derivative of the top and the derivative of the bottom and then using direct substitution. So the first couple examples, we actually have a couple ways to do it because we already knew how to do them, but L'Hopital's work. And then the next few examples, we kind of have no choice but to use L'Hopital. So here's the first one. Limit as x approaches 3 of 2x minus 6 over x squared minus 9. If you were to use direct substitution, that does in fact lead to 0 over 0. But we know better than to think that that means the limit necessarily doesn't exist. This one, easily factor. So over here on the left, I will factor the top and I will factor the bottom. Excuse me. Let's see, the top factors in 2 times x minus 3. The bottom is a difference of 2 squares. And then, of course, I can cancel as x approaches 3. That's just 2 over x plus 3. And now I can use direct substitution. So I factored, I canceled, then I use direct substitution. I plug in 3 for x, I get 2 over 6, which is 1/3. There's nothing wrong with doing that limit that way, and that's one of the easier ones we would have learned back in August and September, so don't forget about that. But since direct substitution leads to 0 over 0, we can use L'Hopital. L'Hopital says that I can take the limit as x approaches 3 of the derivative of the top. The derivative of 2x minus 6 is just 2. And the derivative of the bottom is 2x. And now if I use direct substitution, I get 2 over 2 times 3, which is in fact 2/6, which does in fact equal 1/3. That doesn't make that a better way to do that particular limit. But L'Hopital's rule, whenever you see a limit on the AP test or anywhere in a calc test, always think L'Hopital. Like you have to make sure the conditions hold. Make sure if direct substitution leads to 4 over 0 or 0 over 9, you can't use L'Hopital. It's got to be 0 over 0 or infinity over infinity. Next example is also one we could have done another way. It says the limit as x approaches infinity, 2x squared minus 7 over 5 plus x squared. Well, excuse me, you'll recall that as x approaches infinity, if the limit exists, that's essentially a horizontal asymptote. So really, you'll recall all we needed was to pay attention to where the biggest exponent is. If it were on top, then the limit would either be infinite or negatively infinite. If the biggest exponent were on the bottom, the limit would be 0 as x approaches infinity. In this case, since the degree of the top and the degree of the bottom are the same, it's 2x squared over 1x squared, and it would just be the ratio of leading coefficients. So it would literally just be 2 over 1, which is 2. Still a very easy limit. Remember, that process of identifying where the biggest exponent is and acting accordingly only really matters as x approaches infinity or negative infinity. You can't do that process as x approaches 1 or 2 or 0. But since direct substitution does lead to infinity over infinity, let's use L'Hopital just to show that we could. Limit as x approaches infinity. The derivative of the top is 4x. Derivative of the bottom is 2x. Now you'll notice that officially, when I plug in infinity, when I use direct substitution, I still get infinity over infinity. I'm not done yet. So we have to use L'Hopital again. If using L'Hopital and taking the derivative of the top and the derivative of the bottom still leads to infinity over infinity, you can use that process again. So this is now the limit as x approaches infinity of just, 4 over 2. That's just the horizontal line at 2, and the limit as x approaches anything would just be 2. So that got us there also. That one probably more so than the first one. If you remember, as x approaches infinity, to just deal with the exponent would have saved you a little bit of time, but only a little bit. All right, 3 more examples, all of which we kind of need L'Hopital's for. All right, limit as x approaches 0 of e to the 2x minus 1 over x. If I use direct substitution, let's see, e to the 2x is e to the 0, which is 1 minus 1. I get 0 on top over 0. So that does lead to 0 over 0. Doesn't mean it doesn't exist. It means that it is a candidate for L'Hopital's rule. So this is now the limit as x approaches 0. The derivative of e to the 2x minus 1. Well, the derivative of e to the something is itself times the derivative of the exponent. So that'll be e to the 2x, and the derivative of 2x is 2. I'll put that out front, 2 e to the 2x. And the minus 1 doesn't have a derivative. And then on the bottom, the derivative of x is just 1. Well, now can I use direct substitution? If I plug in 0, I get 2 times e to the 0. That's 2 times 1, which is 2 over 1, which is, in fact, 2. So just using L'Hopital, we started with direct substitution. We got 0 over 0. We used L'Hopital. We took the derivative of the top, derivative of the bottom. Then we did use direct substitution. So again, many limits become really, really doable with the help of L'Hopital. I can't teach this back in chapter 1 because we don't know how to take a derivative yet. That's why when we teach limits, we can't have this conversation. But now we can, now that we know how to take derivatives. All right, 2 more. What about this one? Limit as x approaches infinity of the natural log of x over x. Well, if I try to use direct substitution, both the top and the bottom are getting infinitely big. Natural log of x, well, the natural log of x looks like this. It is still getting bigger as x gets bigger. And of course, the denominator is getting bigger. So this does turn out to be infinity over infinity. So let's use L'Hopital. So this says the limit as x approaches infinity, the derivative of the natural log of x is 1 over x, and the derivative of the bottom is just 1. And I can do some algebra. This fraction right there is really just 1 over x. Limit as x approaches infinity of 1 over x. Now, I can attempt direct substitution. My denominator is getting bigger and bigger and bigger. My numerator happens to be the fixed number 1. You'll recall, hopefully, that any fixed numerator over an increasingly bigger denominator, as x gets bigger and bigger, we're considering 1 over 1,000, and then 1 over 1,000,000, and 1 over 1,000,000,000, and 1 over 1,000,000,000,000. Those fractions are getting smaller and smaller, and they are, in fact, approaching 0. You could also, once we get to this one, you could also think of this as, as x approaches infinity, where's the biggest exponent? The biggest exponent is on the bottom, which does lead to 0, like we had that conversation 6 months ago also. But L'Hopital worked really nicely there. Okay, last one. It says the limit as x approaches negative infinity of x squared over e to the negative x. Well, if I attempt direct substitution, my numerator is getting bigger and bigger. Negative infinity squared is a bigger and bigger positive number. And e to the negative x, well, as x becomes more and more negative, negative x is becoming more and more positive. So I get e to an increasingly big number, also infinity. So direct substitution here does lead to infinity over infinity. So let's use L'Hopital. This is the limit as x approaches negative infinity. Let's see, the derivative of the top is 2x. And the derivative of the bottom, the derivative of e to the negative x is itself, which is e to the negative x, times the derivative of the exponent. The derivative of negative x is negative 1. I'll put that up front. It's negative e to the negative x. Well, if I were to attempt direct substitution again, I get, let's see, as x, my numerator now is getting more and more negative, 2x as x approaches negative infinity. And my denominator, negative e to the negative x, well, e to the negative x is getting bigger and bigger as x approaches negative infinity, but it's the opposite of that. So I think both of those, it turned out to be negative infinity over negative infinity. And that would still, like we still, using direct substitution, would get this, and that still qualifies us for L'Hopital. So I think I need to take the derivative again. So let's do that. This is the limit as x approaches negative infinity. The derivative at the top is 2. Derivative at the bottom is now e to the negative x again. Now I multiply by negative 1 again. The negative signs cancel out. So I end up with just that. Now I think I can use direct substitution. Because once again, I have a fixed number in the numerator, happens to be 2. The denominator, e to the negative x, as, oh, I forgot a negative sign there. That's a negative, there you go. As x approaches negative infinity, e to the negative x is getting bigger and bigger and bigger. And so I have a fixed numerator over an increasingly bigger denominator, which does in fact trend towards 0. So, the AP test, probably only 3-ish, 2, 3, 4 questions that will make you take some sort of limit. And it might be a real easy, just factor, cancel, plug it in. But be on the lookout for L'Hopital because it does make lots of limits easier. And then the assignment is right here, page 511. This is section 7.7, but I'm not sure we need that. 5 to 19 odd and 22 to 28 all. So that is it for L'Hopital. Have a great day.